Hello, geometry students. I hope you're having a wonderful day. Today we are continuing in chapter 4, and it's all about triangle congruence. Today we're in section 4-3, and it's called Triangle Congruence by Angle Side Angle and Angle Angle Side. So today what I'd like for you to be able to do is to prove that two triangles are congruent by using either angle side angle or angle angle side theorems. So to begin with, what is the angle side angle congruence postulate? It says, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So basically, if you have two angles and a side in between them. So that's what all of this boils down to, is two angles and a side in between them. So that in between is important. Notice that we're using the word included once again, and included means it needs to be in the middle. So in this image, we have angle A is congruent to angle D, angle C is congruent to angle F, and then the side in between the angles that I know, those are congruent to each other as well. This then means that I can conclude that the triangles are congruent. So I'm going to say triangle ABC is congruent to triangle. So I'm going from triangle A, which has 1 mark, so I'm going to start with D. That one has 1 mark. B has no marks, so then I'm going to go to E and then F. So let's look at some images and determine if we can or cannot use angle side angle for these images. So to begin with, we have two angles, and then we know that this guy is congruent to itself. Now, in a previous lesson, we were told that if two triangles have two congruent pairs of angles, then the third pair of angles must also be true or congruent. So I can say that those guys are congruent to each other by the third angles theorem. Then I can also say, here, let me do it in a different color. I can also say that this side right here is congruent to itself by the reflexive property. So now I have an angle, a side, and an angle on my left triangle, as well as an angle, a side, and an angle on my right triangle. So I am able to use angle side angle. So yes, I can use angle side angle on this example. Okay. Let's look at the next one. Here I have two parallel lines, and if we temporarily ignore the up and down lines, I can see that I have a transversal going across this. Remember, when there is a transversal, it means alternate interior angles are congruent. So I'm going to say that this guy is congruent to that guy. And they both share this line LN. So I'm going to say LN is congruent to itself. The only issue at this point is that I don't have enough information to conclude anything else about these triangles. So all I have is one angle and one side. Therefore, I do not have enough information. So not enough information, and we're going to leave it like that because we can't prove anything about these triangles. For the next one, I have a side that is congruent to a side, and then another side that's congruent to another side. Also, remember that these types of angles right here are something called vertical angles. So here I have a side, an angle, and a side, and then a side, an angle, and a side. Notice that side angle side is not the same thing as angle side angle. So I'm going to say no, we can't use angle side angle because this uses side angle side. I have enough information for this guy, but not enough for this one. All right, let's look at another example. It says, which two triangles are congruent by angle, side, angle? So I have a cluster of 3 triangles here, and I want to determine which ones are congruent by angle, side, angle. Here I have P is congruent to U and V. R is congruent to W and T. So all 3 pairs of triangles do have 2 angles, or 2 pairs of angles that are congruent. But notice in this first triangle, this line is in between P and R. So the side that we know is in between the 2 angles we know. In this triangle, the side that we know is also in between the 2 angles that we know. However, down here on triangle STU, this marked line is on the outside of these 2 angles. If I wanted this triangle down here to be congruent, then I would have needed, let me get a pencil so I can erase it. I would have needed that line right there, because then it would be in between these 2, but it's not there. So I then know that that one is not congruent. So I'm going to put kind of a check mark between next to those guys, and I'm going to say triangle PQR is congruent to triangle VXW. So P had 1 mark, Q had no marks, and R had 2 marks. And I kept that in order with my other triangle. Okay, let's look at this next example. I'm looking for 2 triangles that are congruent to each other. Hopefully this middle triangle right here is really sticking out like a sore thumb, because this line right here is not in between the 2 angles that I know. If it were, then I would need it down here, but it is not down there, so I'm going to have to erase that line, and I now know this guy is not the congruent triangle. So I'm going to say triangle OGH is congruent to, so I went from no marks, 1 mark to 2 marks, is congruent to TCA. Triangle TCA. And there you have it. Let's flip this paper over and continue our notes on the back side. So we just did angle, side, angle. Now we have angle, angle, side. All right, angle, angle, side is going to be exactly what it sounds like. We have 2 angles and then a side next to them. So it says if 2 angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So essentially, you need 2 angles and then a side in common. So let's look at our image and see if this meets that requirement. I have G and K being congruent to each other, and I have J and M being congruent to each other. I also have segment HJ congruent to segment LM. Notice how this segment is not in between the angles anymore. It is non-included. But that is okay because this is the angle-angle side theorem. So I am going to say triangle HGJ is congruent to triangle. So I went from no marks, 1 mark to 2. I'm going to say that is congruent to LKM. Remember back from section 4-1, when we are naming congruent figures, the corresponding vertices must match. So I'm going to write that out. When writing congruency statements, corresponding vertices must correlate or match positions. Alrighty. That's just a little reminder. We've already covered that, but I just wanted to tell you again because that is a fundamental part of writing out the answers to these problems. All right, we have a proof, but it's not going to take us too long. It's only 4 steps. So it says use angle, angle, side to show that the triangles are congruent. It says given JL, and there should be a line over that. So segment JL bisects angle KLM, and angle K is congruent to angle M. So I already have K and M being marked as congruent to each other. And JL, this line right here, is bisecting KLM, which KLM, that's this whole guy right here. So that means that this half is congruent to that half. But we are going to have to describe why that is. So step 1, we're going to write our given. So I'm going to say JL bisects angle KLM, and angle K is congruent to angle M. Why do we know that? They told it to us. It was given to us. Okay, step 2. Now, because this said bisects, and remember bisect means cut in two perfectly, that means that these two angles are now congruent to each other. So I'm going to say angle KLJ, so that's the top one. KLJ is this part right here, is congruent to angle MLJ. That's the lower half. But why are they congruent? Why am I allowed to say that? Well, they are congruent because of the definition of bisect. Okay, so far we have 2 pairs of angles that are congruent to each other. Now I need a side that is congruent in both of the triangles. Well, notice that they share this side right here. A triangle is formed up top and a triangle is formed down bottom. And they both have this center line as one of their sides, which means it is congruent to itself. So I am going to say that segment JL is congruent to segment JL. Why? Because of the reflexive property. So now I have 2 pairs of angles in each triangle that are congruent, as well as a non-included side in each triangle. So I'm going to say that triangle JKL is congruent to triangle JML. Why? Because of angle, angle, side. And we're done with that proof. 4 quick steps. We have one last example and then we're done with today's notes. It says, which of the following statements best represents the answer and justification to the question, are the triangles congruent? So I'm trying to figure out, is this triangle congruent to this triangle? All right. So I know that when I have 2 right triangles, they are congruent to each other. So all right angles are congruent to each other. So I know that this guy and this guy are congruent. I also know that this guy and this guy are congruent because they're marked in the image. So right off the bat, I have 2 angles. But also, similar to our problem up here, the triangles share a side in this image. They share this part right here, and it is congruent to itself. So now I have an angle, and a side for this lower triangle, and then I have an angle, and a side for this upper triangle, which means I cannot use angle, side, angle, because the side would need to be in between the angles that I know, but it's not, so it's not that one. It can't be side, side, side because I don't have enough information about all 3 sides. It can be angle, angle, side because I have angle, angle, side, and angle, angle, side. So I'm going to say C, and that's all for that question. So essentially, the two new ways that we have learned how to show triangles are congruent, I'll tell you one more time, is through angle, side, angle, and angle, angle, side. We'll be practicing with this some more tomorrow in class, but until then, have a good night.